Okay, I've got a radar gun that I know is rotating as it's following the car with a angular velocity of 0.1, angular acceleration of 0.025 radians per second squared. Okay, when I'm at 45 degrees, that's pretty much shown here. As it follows the motion of the car along, I have a radius of 200. I want to find the velocity and acceleration of the car. So instantly I see r and theta, I think polar coordinates, right? Which is really what the radar gun is determining. So when I have those polar coordinates, I'm going to go ahead and figure out r dot, and r double dot, okay? So r, again, is the distance away. It's the radius of that curve from where my um, radar gun is. So that's going to be 200. Okay. Now, this is going around a constant or a circular with a constant radius, right? So this car is never getting further away. It's constant at 200 as it goes around the curve. Therefore, r dot and r double dot both go to 0. Okay. Looking at theta, okay, again, oops, not theta dot. We're going to start with theta. Again, theta is 45 degrees, but unfortunately I need to do this in radians when I'm dealing with polar coordinates, which would be over 4, pi over 4, right? Okay. Theta dot is given to me as 0.1, and theta double dot is also given to me at 0.025. So now that I've got all these, I can go ahead and calculate my velocity in the r direction, in both direction. Anyway, go on. Velocity in the r direction is r dot, which is 0. The velocity in the theta direction is r theta dot, which is going to be 200 times theta dot, which is 0.1, which is going to give me 20 meters per second, and that's it, because there is no velocity in the r direction. The theta direction is only in that direction. R direction, again, is out like that. Okay, do the same thing with acceleration, and I get the acceleration in the r direction equals r double dot minus r theta dot squared. Okay, r double dot goes to 0, so all I'm left with is negative 200 times theta dot squared, 0.1 squared, and that's going to give me negative 2 for my AR. Negative means pointing back towards the center, right? R points out. So again, this is effectively, as I go around this constant circle, this is my normal acceleration, okay? My acceleration in the theta direction is r theta double dot plus 2r dot theta dot. Again, r dot is 0, so that goes to 0, okay? So all I'm left with is 200 for r, and then theta dot of 0.025, like so. And from that, I get 5. So to find the magnitude of the acceleration, that's just going to be 2 squared plus 5 squared to get the total acceleration, which is going to be 5.39, and that would be meters per second squared. So again, go through when you have polar coordinates, find r dot, r double dot, theta, theta dot, theta double dot, and then plug those into the equations to find velocity in the r and theta direction and acceleration in the r and theta direction to calculate what you need to.